Alright, so we're going to do synthetic division, the messy cases, also known as the ones where you end up having to deal with fractions. Alright, two options. I used to call them two good options, but you have two choices. Either one is perfectly legitimate. Both of them, you have to be careful. In different problems, one of them is easier to work with than the other, but there's not really like a solid, ooh, this one's going to always be easier than that one, or ooh, this, when I see this, I do that. You end up getting a personal preference, and you end up doing which one you want. You can divide everything by the leading coefficient of the divisor. Oh, I actually didn't show you why we would do this. Hold on. Let me just write down the choices, and then we'll... No, you can read it and all that good stuff. Pause and all that good whenever you need to. Here's one you would do it. Let's look at the... Let's say we had something bad here. Alright, you're going to do this whenever you have the case where you have a number in front of your x. That's your divisor. Anytime you have a coefficient that's not 1 in front of there, you're going to end up dealing with fractions at some point in time, in some way. It's just, welcome to it. There's going to be fractions somewhere. Now, usually it's going to work out better than it seems at first, but there's going to be fractions. And you either deal with it by dividing everything by whatever's in front of everything. I'm talking here and there. Whatever's in front first or last. This one is nice because you get it out of the way. You do it once, you don't worry about it anymore. Then you're just dealing with your stuff. However, sometimes you end up seeing lots of fractions throughout the thing the whole time. This one's nice because I don't usually have to see fractions. Sometimes I don't have to see fractions throughout the entire time. Sometimes I do. But I do have to remember to divide that after I think I have an answer. Either way, let's just do it and see what happens, and I'll show you what I'm talking about, because sometimes the instructions are harder to figure out than seeing an example. So write down, pause and write down those two things. I'm going to do this problem right here both ways. Alright, so if I divide everything by 3 first, so I'm going to divide that first. Alright, first let's not make sure, this is in standard form, 3, 2, 1, 0, right? No powers go back up. Missing terms, I am missing a 0. 4, 3, 2, 1, I need a 0. So, there's mine. I'm not a big fan of parentheses. I know they're there. Alright. No missing terms, and my divisor is linear. Yes. So, good so far. Now, I'm going to divide everything by 3. Alright. That gives me 3 divided by 3 is just 1, so it gives me x to the 4th minus 5 over 3 x cubed plus 1 over 3 x squared plus 7 over 3x plus 0 over 3 is just 0, divided by 3 over 3 is just 1, and 1 over 3 is 1/3. And now I get right into synthetic the way I've Been doing it this whole time. Take this guy, set it equal to 0, find out what x gets me. There, that'd be x equals negative 1/3. Make that my little box. Alright, take all my coefficients. 1, negative 5 over 3, 1 over 3, 7 over 3, 0. Draw my line. Note where my remainder is going to be. And now, since I already divided, I can just get to work. Bring down my 1. 1 times negative 1/3 is negative 1/3. Watch what happens with the fractions. A lot of times they end up conveniently disappearing. That's because your textbook and your teacher don't absolutely hate you. They want you to see fractions, but they also want you to not be scared of them, so you end up seeing success. Negative 5/3 and a negative 1/3 is negative 6/3, which happens to be negative 2. Alright? Negative 2 times negative 1/3 is positive 2/3. 2/3 and 1/3 are 3/3, which is just 1. 1 times negative 1/3 is negative 1/3. Right? Negative 1/3 and 7/3 is 6/3, which is also just 2. And 2 times negative 1/3 is negative 2/3. So my remainder is negative 2/3. Now, I like working right to left here. I don't like going I can't talk. I like going right. I like going backwards. This shouldn't be an x to the third, and then second, and then first, and then the constant, and then the remainder. I like starting with the remainder. So I know it's going to be a big fraction. I like to take my top on the top and the bottom on the bottom. And what I'm dividing by is x plus 1/3. Right. This is a 2. It's positive. That's an x. It's positive. That's an x squared. It's negative. This is an x cubed. And there's my answer. Alright. Do the same problem the other way. Everybody's good? I'm going to start right here where I already have my missing term filled in. Note that's the answer. Alright, now I'm not going to give all those fractions at the beginning. I'm going to just remember to do that at the end. So now I just set this equal to 0. Subtract 1 from each side. 3x equals negative 1. Divide by 3. Divide by 3. X equals negative 1/3. That's what goes in the box. Notice no matter what, I'm going to have a fraction in the box, which means no matter what, I'm going to be dealing with fractions throughout this whole thing. You see a number in front of the x, you know there's no way to avoid some fractions. Alright. 3, negative 5, 1, 7, 0. At least I don't have tons of fractions. Watch what happens. This is still kind of cool. I bring down my 3. 3 times negative 1/3 happens to be negative 3 over 3, which is just negative 1. Negative 5 and negative 1 is negative 6. Negative 6 times negative 1/3 happens to be positive 6 over 3, which reduces to 2. 2 plus 1 is 3. 3 and negative 1/3, negative 3/3, which ends up being just negative 1. Negative 1 and 7 is 6. 6 and negative 1/3 is negative 6 over 3, which is just negative 2. And that adds up to negative 2. It looks kind of nicer. Except now, I have to remember to divide everything by 3. Right? Divide everything by 3. 3 over 3. Oh, I'm going to go backwards. So, my remainder is negative 2 over 3. Right? Now, I'm still going to use what I had right here. Okay? What I was dividing by was really x plus 1/3. Right? That's what goes in here, because that's what I was technically dividing by according to this box. Don't lose that. That's going to save you. Alright, when I multiply that out, I'm going to get a 3x plus 1. 6 divided by 3 is just 2. It's positive. I now have an x. 3 divided by 3 is 1. That's just positive. Now I'm on x squared. Negative 6 divided by 3 is negative 2. Now I'm on x cubed. And 3 divided by 3 is 1. Same answer as before? I think so. And those are the two ways of dealing with fractions.